Hi, I'm Samir Desai, and in this video, I'm going to teach you how to rank the acidity of alcohols.
The hydroxy group of an alcohol is weakly acidic because it has the ability to donate its hydrogen proton. Alcohols contain an OH, so they are often incorrectly labeled as a basic molecule, but keep in mind that the entire OH would have to dissociate here for it to be basic. Since only the hydrogen is dissociating, it is acidic. When the alcohol deprotonates, or donates its hydrogen ion, the resulting conjugate base is called the oxonium anion. The strength of an acid is determined by the stability of its conjugate base. The more stable the conjugate base, the stronger the acid. Two factors play a role on the stability of a conjugate base: resonance and the inductive effect. Both redistribute the negative charge from the oxonium anion across the molecule. The better distributed the negative charge, the less negative charge there is on the oxygen, and the more stable the conjugate base. As mentioned before, the more stable the conjugate base, the more acidic the alcohol. Resonance is where delocalized electrons are shared across the molecule through pi orbitals on double bonds. So the electron on the negative charged oxygen can shift down here, which causes the electrons in this double bond to shift over here to prevent any carbons from having more than 4 bonds, creating a cascade of electron movement seen by all the arrows here. This image in the center is useful because it tells you right away that there is resonance and the pattern of the electron delocalization. The inductive effect is also a way to redistribute a negative charge. Due to the difference in electronegativity, groups like the electronegative fluorine seen here are able to withdraw electrons from the negatively charged oxygen. The more electronegative groups on a molecule, the more stable the conjugate base and the stronger the acid. Let's use this information to rank the acidity of alcohols. Place the following alcohols in order of increasing acidity. Let's start by drawing out these molecules. These 4 molecules are all 6-carbon cyclic molecules. Cyclohexanol is drawn as seen, but the remaining 3 are aromatic rings containing double bonds within the ring. Phenol is drawn as seen. 2,4-dinitrophenol will have 2 nitro groups here and here. 4-fluorophenol will have a fluorine here. And there we have the drawings. The conjugate bases will have the hydroxyl group deprotonated and look like this. Let's take a look at which of these conjugate bases have resonance. The first thing to look out for is double bonds, which allow for pi orbital sharing. The first 3 molecules have resonance. And this allows for the redistribution of the negative charge on the oxygen across the molecule. Since cyclohexanol doesn't have resonance, the base is not as stable as the others, meaning it will be the weakest acid out of the 4. The next thing we look out for is the inductive effect. Electronegative groups will withdraw electrons from the negatively charged oxygen. Phenol has no electronegative groups. 2,4-dinitrophenol has 2 electronegative groups that can withdraw electrons, and 4-fluorophenol has 1 electronegative group. 2,4-dinitrophenol best distributes the negative charge across the molecule and will be the most acidic. 4-fluorophenol will be the second most acidic, and phenol will be the third most acidic. This concludes the lesson on ranking the acidity of alcohols. So hopefully you're now able to identify alcohols and rank them based off the stability of their conjugate bases.